Well, welcome back to Workshopfriend, and this is the final installment of making a large fixed steady for my Myford lathe. So to start with, we need to drill the clearance holes for the clamping bolts. These are the bolts which hold the fingers in place, and they come up from underneath the casting and they screw into captive nuts which slide nicely in those slots. So the first task is to drill the holes in the center of the slots, which we've already formed. To do that, I made a little jig. That will simplify things enormously. It's quite difficult to get a measurement of the center of that slot, so I thought this was a better solution. So I've put a nominal drill size in there, which will enable us to start drilling, and then we can open it out to size later. So as a cheap and ready alternative to a vertical mill with plenty of headroom, I use my good quality pillar drill, and you see this used quite a lot in my videos. So the jig is enabling me to precisely locate the hole. I'm going to then open that up to the required size. I want to be able to reuse the jig for the other holes, so I'm carefully moving it by undoing just one of the clamps and then keeping the work in position so that I can open up the hole. One accurately located hole, now to do the other two. I'm using my recently made DTI holder to center on the 1/4 inch hole. Actually it's 1/4 inch plus a 1/64, it's a clearance hole for 1/4 inch bolt. So now I've got the center of the mill over the hole. I'm going to put the boring head in there and counterbore that hole. The original Myford fixed steady had counterbores for the washers. You see here that I'm making the counterbore for this size of washer, but later I decided to make my own larger washers, and so I increased the counterbore size. Now to produce the two counterbores in the lower casting. Again, I'm using the homemade DTI holder, this time with a 1/2 inch stub mandrel. If you'd like to see my video on making the DTI holder, then do have a look at this link I'm including here. It looks a bit laborious, but with the practice I got quite quick at this and was able to center on the hole fairly easily. Now swapping out the ER32 collet holder for the boring head and getting ready for counterboring. I temporarily removed one of the clamps to get space for the DTI holder. I'm now putting it back in its correct position to provide adequate clamping. I don't want this sliding while I'm counterboring. Even though this setup is quite rigid and the machine is quite capable of taking broad cuts along the face of the cutting tool, I still found it necessary to take 2 depths of cut to get the full rim width of the counterbore. This is one of the better quality washers I made myself off camera. Now just making sure it's a nice fit in that counterbore. It's now time to drill and tap the 1/4 UNF holes for the adjusting screws. Now you may say, why 1/4 UNF? Why not a more common thread? Well, I could have gone with M6, except that all the other threads are imperial, and I thought it was a bit odd to have one metric thread. It also means I have one common spanner size for these adjusting screws and also the clamp bolts. The other thing we need to do now is determine the position of this. So I've already put marking blue on there. We're going to set this horizontal by clocking on the slot here, pick up the center line and transfer that onto the end. And the other dimension will be just measured from this machined face. So we'll center pop those and take those over to the drill for drilling and tapping. Had my milling machine had a greater height, then I could have done it all in one setting, but mine really isn't a vertical milling machine, it's a horizontal, and there isn't a lot of vertical room, so I have to do it this way. This looks trickier than it really is. I'm just using the DTI to get that slot horizontal, and then I'll carefully clamp it down. It's always a good idea to check again after clamping. As you can see, the base casting was a little more difficult to hold, but it was possible to get both those slots lined up. Now that the slot is horizontal, I'm using the drill guide to pick up the center of the hole and transfer that to the extremity of the finger where the hole will be drilled. I've set the odd leg calipers to the correct distance and marking off for the machined face on the end, and then we'll center pop and take that over to the drill. Now repeating the process on the slightly more difficult to hold base casting. You can see the setup here on the angle plate. Angle plates are so useful, and having good angle plates and clamping arrangements in your toolbox I think is an essential part of your kit. At last we have finished the machining of these castings. I've deburred the corners and made sure there are no sharp edges. Off camera I have also radiused or blended the two radii here on the hinge so it comes together nicely, and similarly on the clasp side I have blended these two so that they match. Cosmetic really, but it just finishes it off nicely. So I'm going to remove the bluing, degrease everything, clean everything up, put some paper down here and start to just fill some of the imperfections. The paint can be drying, etc., while I work on the clasp bolt which goes in here, the pin and the clasp bolt. The clasp bolt is made from a piece of EN8 medium carbon steel. I'm having to make this from round, hence quite a lot of roughing to get this down to the right thickness. Having reduced one side to the right depth, I've turned the work over and now resting it on parallels, carefully tapping it down with a hammer as I tighten the vise. And as a result of this, when I finished the work and took it out and measured it with a micrometer, it was within 1/1000th of an inch of parallelism, which I thought wasn't bad. So this is the thickness now. I measured the slot and made to fit. So now I've rotated 90 degrees and we're going to bring this down to the maximum width, and that requires me to take 0.156 inches off each side. So by taking off each side, hopefully we'll minimize distortion. The work's now transferred to the 4-jaw chuck in the lathe. That was necessary because I needed to offset the work to get this 1/4 inch bolt along the right center line. And that required a little bit of careful fiddling around with the DTI. I'm now grooving the material in preparation for screw cutting, and I'm using my inverted rear mounted parting tool. I can now screw cut the 1/4 by 26 TPI BSF thread. After roughing out with a few passes, I then complete the thread with a die. Now I'm just facing the thread to the correct length, and following that I'll put a 45-degree chamfer on the end. I picked up the center line, and that will be scribed on the body there, ready for marking out the center line of the cross hole, the 3/16 cross hole. There's a couple of relieved surfaces which are 1/16 of an inch from each side, so I can just turn the work over and repeat that scribe line again. This will be handy when we go to the milling machine as a guide. And then with the component on the end, I can mark out the end of the work because I've got a little excess material. And now the center line of the 3/16 cross hole, which is also the center line of the 3mm set screw. And then finally, there's a couple of lines which need to go in to show how far to extend that recess. This all makes for easier fitting of the bolt in the slot for the clasp mechanism. If I'd left it the full length, it might have been a bit more difficult to close the bolt. There we are, finished. So this is now ready for drilling, and I'm going to use my smaller drill for this because it's a bit more sensitive. I've got a very fine drill here to make sure I can pick up the center pop neatly. I'm taking my time here at this stage. I do not want to make any mistakes. And then I'm going to open up gradually until I get to a drill which is just a few thou under 3/16, and then finally ream at 3/16. After deburring the holes I've just drilled, I'm going to rotate the work 90 degrees, ready for the tapping drill for the 3mm thread. This is one place I used a metric thread because I couldn't find a ready alternative for such a small set screw. Even though this is a light pillar drill, this is rather a clumsy setup for tapping an M3 thread. Back to the milling machine to relieve the two areas which I previously marked out. And then finally reducing the bolt to the required length. Okay, I've completed the bolt. It's this curious shape on the end here because I need to ensure that it can rotate sufficiently to disengage. So that's completed, and I've also made the pin, the 3/16 pin that goes through there, and it's held in place with a set screw. So just as I chemically blackened the washers, I did that already to match the other features which are coming across from the other fixed steady. I'm going to chemically blacken these two. So that's the bolt, the cross pin, and the main bolt for the hinge. There's also the washer which fits on the bolt, and this nut here. Unfortunately, I haven't got a chemically blackened commercial nut available. There's this one which is plated. I don't think it's going to blacken, but I'll just throw it in and try it. This is a proprietary kit with alkaline cleaner, the chemical blackening solution, and then some dewatering oil afterwards, which I assume just makes sure that the surface, which is slightly porous, isn't susceptible to moisture. So we'll go ahead. I've got the alkali solution in here, and the instructions say that it should stay in there for 10 minutes, and then we move to the blackening solution, and then finally the dewatering oil. So I think it's 10 minutes, 10 minutes, and then 5 minutes. So we'll start with these. I need a bit more in there, I think. So we'll leave that for 10 minutes, and then we'll transfer to the blackening solution. Okay, 10 minutes have elapsed at least, so the instructions say wash in water, tap water. Wow, that's turning quickly. Amazing. And that's to stand for 10 minutes. Okay, we're ready for assembly. Before we do that, I'll just show you how the bolt came out, and the hinge pin, the large bolt we made a couple of videos ago. That blackening certainly takes very quickly. I don't know how durable it is. I have no idea as to whether it provides any corrosion protection, but it matches the other parts which were already blackened from the original. So here at last we have the large Myford fixed steady in place, and this is the job that it was intended for. This is a very specific job that I have planned for future videos. It's for my milling machine. This is a piece of steel nominally 2 3/4 inch diameter, which I need to reduce to 2.5 inches with a few inches off the end. This is currently 3 foot long. It weighs around about 20 kilograms. And you probably would be right in saying that this is too big for a 3.5 inch lathe. But I haven't got my Colchester student available, it's overseas, and so I've got to do this on the machine I have available. So I designed this fixed steady with this job in mind, and there are a number of features which I'm now very glad I took the time and effort to get right. The first is this hinge and the very positive action with no slop in it, and also the clasp with the way that the surfaces come together, and the way that the bolt that comes in here actually locks the two halves together positively. So there's a locking action there, and then we just nip it down like that. And what I found is that that gives good repeatability. The second feature, which I'm really glad I added, are these jacking screws. So not only jacking screws, but jacking screws with fine threads. And I found that using these jacking screws, slackening off the clamping screws, allowing the fingers to move in a very controllable way, and coupled with the two DTIs, I was able to align this actually very quickly. I think it took me about 15 minutes, and I got this running concentrically and in line with the axis of the lathe. So that wasn't as major a task as I thought it was going to be, and all because I had these jacking screws. So I used these two DTIs, one in the vertical plane and this one here, which is probably difficult to see, measuring the horizontal movement. And of course, by measuring off the saddle, I am effectively checking alignment with the bed. And I was able to jack the screws and get this lined up both in the horizontal and the vertical directions. So that's great. And of course, ensuring that it's concentric with the axis of the lathe, so getting that right too. And having done that, I thought let's just check the vertical alignment with the calipers and a couple of parallels off the bed, and I was very pleased to discover that lines up as well. So that's a good correlation. So let's see it turning. So there we are, a little 3.5 inch lathe turning a piece of 2 3/4 inch steel by 3 foot long. I don't think it was ever intended for that. Anyway, thank you for staying with me for this 4-part series on this fixed steady. Maybe there's something here that was interesting for you. Maybe you'd like to produce one yourself. I have some drawings available if you'd like to see them or have them. I hope you'll join me next time for some more work on the Adcock and Shipley milling machine, including the machining of this shaft. So thank you very much.